and division of radical expressions. Let's start with a simple problem. The square root of 3 times the square root of 3 plus the square root of 6. Okay, now the key to multiplying radical expressions is the distributive law, the same tool that we used when we multiplied expressions that did not involve radicals. Just to recall, the distributive law says that A times B plus C is equal to AB plus AC. That is, we distribute the A through the parentheses. In much the same way, over here we're going to distribute the square root of 3 through the parentheses. And we will get the square root of 3 times the square root of 3 plus the square root of 3 times the square root of 6. Now, the square root of 3 times the square root of 3. You can make use of the fact that the square root of A times the square root of B is the square root of AB. Let's assume here that A and B are positive. Okay, and in which case we get the square root of 9. The positive square root of 9, of course, is 3. Or you can simply say the square root of A times the square root of A is the square root of A squared, and if A is positive, that is just A. Whereas this is a special case. When you're taking the square root of a number times the square root of that same number, it squares out. You just get the number that's under the radical sign. So for the square root of 3 times the square root of 3, we get 3 plus the square root of 18. This is the square root of 3 times the square root of 6 is the square root of 3 times 6, or the square root of 18. Now we're not quite finished yet because we would like to leave our radical in simplest form. Okay. For a radical to be in simplest form, we try to pull as much as we can out from the radical sign, out from under the radical sign. And the trick is to look for in this case, the square root, a perfect square factor of 18. You can write 18, of course, as 9, which is a perfect square times 2. And this is now 3 plus the square root of 9 times the square root of 2. 9, of course, was chosen because it is a perfect square. It is true that 18 is 6 times 3, but that would not help us to reduce this. Here we can write this as 3 plus, now the square root of 9 means the positive square root of 9, which is 3. We get 3 plus 3 times the square root of 2. And this is as far as you go on this problem. Okay, do not think that you can simplify further and make it 6 the square root of 2. Just want to remind you, if you have 3 the square root of 2, and you add to it 3 the square root of 2, this you can factor as square root of 2 times 3 plus 3, and you get 6 the square root of 2. This is like combining like terms. Okay? 3 the square root of 2 plus 3 the square root of 2, that is 6 the square root of 2. This is 3 plus 3 the square root of 2. These terms, in a sense, are not like terms. They can't be combined any further. So that is the end of that problem. Okay, let's try another one. 3 times the square root of 5 times the square root of 5 minus the square root of 2. Once again, using the distributive law, we'll get 3 the square root of 5 times the square root of 5 minus 3 the square root of 5 times the square root of 2. This gives us 3 times. Now, the square root of 5 times the square root of 5, of course, is just 5. Okay, we're taking the square root of a number times the square root of the same number. We just get the number without the radical sign, minus 3 times the square root of 5 times the square root of 2. That's the square root of 10. Okay, so we get a final answer of 15 minus 3 times the square root of 10. And this is as far as we go on this. (15 minus 3 times the square root of 10). Okay, let's try another problem. The square root of x plus 3 times the square root of x minus 5. So far today, we were multiplying, say, binomials. Okay, we're multiplying a sum of terms by only one term. Multiplying, say, a binomial by a monomial. Straight one application of the distributive law. A times B plus C is AB plus AC. Over here, we are multiplying two binomials. Okay? You could use the distributive law repeatedly and work this out. We have a rule for working out a problem like this, which comes from the distributive law. We do this by the FOIL method. When you're multiplying two binomials, two terms by two terms, we do it by FOIL, first, outer, inner, last. That is, first we multiply the first terms and the outer, the inner, and the last. Okay, let's try that. The first terms gives us the square root of x times the square root of x. Assume here, of course, that x is positive. And outer terms, we have minus 5 the square root of x. Inner terms, plus 3 the square root of x. And last terms, minus 3 times 5. Okay? The square root of x times the square root of x. We're assuming here that x is positive is just x. Just like the square root of 5 times the square root of 5 was 5, the square root of x times the square root of x is x. The two middle terms are like terms we can combine. Minus 5, the square root of x, plus 3, the square root of x. Minus 5 plus 3, that's minus 2, the square root of x, minus 15. Giving us a final answer of x minus 2, the square root of x, minus 15. Okay, let's try another problem like this. 2 the square root of x minus 3 the square root of 2 times 3 the square root of x plus 4 the square root of 2. Once again, we're multiplying binomials, and we're going to do it by FOIL. First, outer, inner, last. Okay, first, 2 the square root of x times 3 the square root of x. I'm going to rearrange it so that the constants appear first. So we'll have 2 times 3 the square root of x times the square root of x. Outer, we have 2 the square root of x times 4 the square root of 2. So we'll write this as plus 2 times 4 the square root of 2 times the square root of x. For inner, the inner terms, minus 3 times 3 times the square root of 2 times the square root of x. And last, minus 3 times 4 times the square root of 2 times the square root of 2. Let's see what we have. 2 times 3 gives me 6. The square root of x times the square root of x is x, so this gives us 6x for the first term. Plus 2 times 4, that's 8. The square root of 2 times the square root of x is the square root of 2x. The square root of ab is the square root of a times the square root of b, and you can use this either way. Minus 3 times 3, 9. The square root of 2x, the square root of 2 times the square root of x, square root of 2x, minus 3 times 4, which is 12, times the square root of 2 times the square root of 2 is just 2. This gives us 6x. Now, plus 8, the square root of 2x, and minus 9, the square root of 2x, are like terms we can combine. 8 minus 9, the square root of 2x, or minus 1, the square root of 2x. Generally, we leave out the minus 1. Okay, it's implied here. Minus 1, the square root of 2x, minus 12 times 2, minus 24. So we get 6x minus the square root of 2x minus 24 as our answer for this problem. Okay, let's assume, once again, that A and B are positive numbers. A is greater than 0. Positive B is greater than 0. It's positive. We know that the square root of AB is equal to the square root of A times the square root of B. Some people like to go a little further and extend this rule to addition, and it doesn't work. The square root of A plus B is not equal to the square root of A plus the square root of B. Okay? So although it works for multiplication, the square root of a product is the product of the square root of the factors. It does not work for addition. Okay? The square root of A plus B is not the square root of A plus the square root of B. To see that it doesn't work, all we need is one counterexample. There's one problem for which it doesn't work. Let me give you one. The square root of, say, 64 plus 36 is not the square root of 64 plus the square root of 36. Just to show this to you, the square root of 64 plus 36, of course, is the square root of 100. The positive square root of 100 is 10, whereas the square root of 64 by itself gives you 8. The positive square root of 36 is 6, and 8 plus 6, of course, is 14. These are not equal to each other. Okay? The square root of a sum is not equal to the sum of the square roots of the individual terms. Okay, so don't try to improve on the mathematics. Just use the rules that were given. It works for products. It does not work for addition. Okay, now you may say, well, I never would have done it for the square root of 64 plus 36. Perhaps not. But ask yourself if you would have done it for something like this. This is the real problem. People do things with letters that they would never do if they were actual numbers, okay, where the letters represent, say, variables. The square root of A squared plus B squared is not equal to the square root of A squared plus the square root of B squared. In other words, the square root of A squared plus B squared is not equal to A plus B. Somehow you'd never do it with the numbers, but maybe you would do it with letters in here. Okay, this is what I want you to remember to avoid. Okay, you cannot take the square root of this term and then add to it the square root of that term. This is incorrect. Okay, let me give you one more thing that you're not allowed to do. Okay, you're aware of the fact that A minus B squared, at least I hope you're aware of the fact that A minus B squared is not A squared minus B squared. You are not allowed to, say, distribute the power through the terms. We all know that A minus B squared, which is A minus B times A minus B, is equal, by FOIL, A squared minus AB minus 2AB plus B squared. Okay, so it is incorrect to distribute the power through. Let me give you an example. Let's say we have the square root of 100 minus the square root of 36 squared. This is not equal. You cannot say square this and subtract off this squared. This is not 100 minus 36. To find out what it is, the square root of 100, that's 10, minus the square root of 36, that's 6. 10 minus 6 squared, that's 4 squared, or 16. This, of course, is 64. So they're not equal. You are not permitted to just distribute the power there. Okay? What you may be thinking of is something like this. Let's try a problem. The square root of 7 minus 2 times the square root of 7 plus 2. Let's just multiply these binomials using FOIL. First, the square root of 7 times the square root of 7. Outer, plus 2 the square root of 7. Inner, minus 2 the square root of 7. Last, minus 2 times 2. Giving us square root of 7 times the square root of 7, 7. The outer and the inner drop out. Plus 2 the square root of 7 minus 2 the square root of 7 gives you 0. Minus 2 times 2 minus 4 gives us 3. This is a consequence of the fact that a minus b times a plus b is a squared minus b squared. So while a minus b over here, a minus b squared is not a squared minus b squared, you cannot distribute the power. If you multiply a minus b times a plus b using FOIL, you get a squared plus ab minus ab, they drop out, minus b squared. Okay, so if you're looking for an a squared minus b squared, it can be found by multiplying a plus b times a minus b. And this will be useful to us when we want to rationalize denominators of expressions involving radicals where there is, say, a binomial in the denominator. In the last videotape, you learned how to rationalize denominator when there is only one term in the denominator. And we'll come back to that a little later. Right now, we're concerned with the problem of rationalizing a denominator where there is more than one term in the denominator, in particular a binomial. Let's look at this problem. So we have 12 over the square root of 7 minus 2. Okay, when I say rationalize the denominator, what I would like to do is get a fraction equivalent to this one, say, or an expression equivalent to this one, for which there is no radical in the denominator. The radical in the denominator has been replaced by a rational number. So we're rationalizing the denominator. Okay, we would like to replace the denominator that we have by a rational number. Now, we know we're always permitted to multiply the top and bottom of a fraction by the same non-zero quantity. And I'm going to select the non-zero quantity that I multiply the top and the bottom by very carefully. I know that if I start with the square root of 7 minus 2, if I multiply by the square root of 7 plus 2, the radicals drop out, and I am left with a rational number. And that's my object. That's what I'm going to do here. We multiply the top and bottom by the square root of 7 plus 2. In other words, if you think of this as, say, a minus b, we multiply by a plus b to get a squared minus b squared. So if there were any radicals in here, they would drop out. They would square out. Let's see what we have. On the top, we have 12 times the square root of 7 plus 2. And on the bottom, we have, by FOIL, but we've already done the work over here, the square root of 7 minus 2 times the square root of 7 plus 2 just gives us a minus b times a plus b, a squared minus b squared. You don't really have to go through the FOIL method. If you see it as a minus b times a plus b, it's just a squared minus b squared, the first squared minus the second squared. 7 minus 4, or 3. The bottom is just 7 minus 4. This squared minus this squared. So we get 12 times the square root of 7 plus 2 over 3. We can divide numerator and denominator here by 3. 3 divided by 3 gives you 1. 12 divided by 3 gives you 4, for a final answer of 4 times the square root of 7 plus 2. I would like to finish this tape by doing one more problem involving rationalizing denominators, slightly more complicated problem. I would like you to rationalize the denominators in this problem and simplify at the end. Rationalize and simplify. We have 6 over the square root of 5 plus the square root of 3 minus 10 over the square root of 5. Okay, we have two fractions. One of them is the kind we just considered, where we have a binomial in the denominator, and one is the kind that we considered in the last tape, when we only have one term downstairs. We'll work with each fraction separately. You don't have to have one thing that works for the entire problem. We'll deal with each fraction separately. For the first fraction, 6 over the square root of 5 plus the square root of 3. For this fraction, I will rationalize by multiplying top and bottom by the same quantity chosen to remove the radicals in the denominator here. If you think of this as, say, a plus b, then what we need is a minus b here. See, in the last problem, we sort of started with the a minus b, so we multiplied by a plus b. We call that the conjugate. In other words, if you start with a plus b, you need a minus b. If you start with a minus b, you need a plus b. So the net result is a squared minus b squared, and the radicals square out. But of course, if you multiply the denominator by this, you must also multiply the numerator by the exact same thing. So you have not changed the value of the expression. On the second fraction, this is the simpler kind where you just multiply the numerator and the denominator by the radical in the denominator, namely the square root of 5. This is if there's only one term in the denominator, and here's if there are two terms. Okay? Now, on top here, we have 6 times the square root of 5 minus the square root of 3. And on the bottom, we have a plus b times a minus b. You can use FOIL, or you can just say this is a squared minus b squared. This squared minus this squared gives you 5, minus this squared, which is 3. Minus, here we have 10, the square root of 5, over the square root of 5 times the square root of 5 is just 5. I'm just going to rewrite what we have down there up here so that we can finish off the problem. Okay, I'm just rewriting this. 6 the square root of 5 minus the square root of 3 over 5 minus 3 minus 10 the square root of 5 over 5. Okay, just rewrote it up here. 6 times now the square root of 5 minus the square root of 3 over 5 minus 3, which is 2, minus 10 the square root of 5 over 5. All right, we can, in the first fraction, divide numerator and denominator by 2. 2 divided by 2 gives you 1. 6 divided by 2 gives you 3. In the second fraction, divide numerator and denominator by 5. 5 divided by 5 gives you 1. 10 divided by 5 gives you 2. Remember that there are 1s down here, not 0s. Okay, on top we're left with 3 times the square root of 5 minus the square root of 3 minus 2 the square root of 5. Distributing the 3, 3 the square root of 5 minus 3 the square root of 3. Don't forget to send it all the way through. Minus 2 the square root of 5. And to simplify, these two terms can be combined. 3 the square root of 5 minus 2 the square root of 5 gives you 1 the square root of 5 minus 3 the square root of 3. And this brings us to the end of this problem and also to the end of the tape.